Hi everyone, welcome back. This is our lesson on inequalities word problems. So we're going to start off with talking about what are some words for inequalities. So when we think about words that are going to mean less than, typically another one that kind of comes to mind is fewer than, because you're still talking a number that's smaller, which kind of brings us into smaller than. If I told you I needed to cut a piece of ribbon that was smaller than 36 inches, you would tell me that it would be less than 36 inches. It could also be below 36 inches. It could be under 36 inches. And we could even say the word beneath. It's another good example. Those are all kind of signaling to me that I'm talking about a less than situation. Kind of flipping that over, if we talk about greater than, this would be more than, above, kind of going off of the below, the opposite of that would be above. Under, we could say over, and beneath we could say like exceeding. So it exceeds, it goes over. I want a piece of string that exceeds, is greater than 36 inches would be an example here. The last two with the or equal to part kind of gives us a couple more words to work with. The first one that I'll bring up with less than or equal to is at most. So if I told you the amount of money in my wallet is at most $10, you could know that it would be $10 is like the absolute maximum, which is another word actually here, maximum. So the amount of money in my wallet would be less than that, or it might actually be that. You could say is no more than. The amount of money in my wallet is no more than $10. You could go with not above, because that would signal to someone that it can be equal to that, but it's not going to go over. It'll stay under, so less than. We can also here say does not exceed. Again, it doesn't go above. And those are pretty much some of the major words that we'll kind of see with less than or equal to. So kind of think about that, and I'll flip it over for the greater than or equal to side. If this is at most, this is at least. Because least would mean the smallest that it can be. We want it to be greater than. So is at least, it's this amount. We'd want at least, I need at least $5 for lunch. So I'm going to need $5 or more in order to actually be able to buy my lunch. We can also say no fewer than. I need no fewer than $5 to buy my lunch. We can also say for this one, not under. I'm going to need not under $5 to buy lunch, so give me more than $5. And then going off of this one, this is maximum over here. We can say this one would be a minimum. The minimum I need to buy my lunch is $5. So, Mom, give me $5 or give me more. I'd appreciate more, preferably. Okay? If you hear clunking, that's my dog playing. Represent each of the following as an algebraic inequality. X is at most 30. So X is at most tells us that we have to keep it under, so it's less than or equal to 30. This one, the sum of 5x and 2x, and sum tells us to add, is at least 14. So 5x plus 2x is at least. That tells me it's going to be greater than or equal to 14. The product of x and y, product tells me I'm multiplying. So we're going to have x times y, or xy, is less than or equal to, well, that one's less than or equal to 4. 5 less than a number y. So if you have $20 and I have 5 less, that means I have 20 minus 5. So 5 less than a number y really means y minus 5. So we're going to have y minus 5 is under. So under is telling me less than. I need to keep that number below less than 20. Take a look at this example here. It says the cost of a gallon of orange juice is $3.50. What is the maximum number of containers you can buy for $15? So I want to buy more than one at $3.50. So we're going to say $3.50 X. And our kind of what we used to call our equals number is 15 here. We want to know how many we can buy for 15 bucks. So for us, using an inequality, we have to stay under 15, so that's going to be less than, but we can be equal to because we are allowed to actually spend it. So if I divide by 350 on both sides, I get x is less than or equal to, and you can use your calculator, and I'm going to get 4.2857. So let's just say 4.3, because we're talking about containers of orange juice. So x is less than or equal to 4.3 containers. I'm not going to buy 0.3 containers, so the most that I can buy is actually 4 containers, because x has to be less than this number, and the next whole number of containers less than 4.3 would just be 4. So we'd say 4 containers then. On the next page, which statement is modeled by 2p plus 5? So we need to realize we're multiplying 2 times p and we're adding 5 is less than. So if I'm going through, I'm looking for less than. This one says is at least, is less than, is at most, is. So is signaling to me that we have an equal sign. Cross that off right away. At least, if you remember back from our chart over here, is at least tells me that we want to be greater than or equal to, because we want to be over that. That is not a less than symbol, so cross that guy off. 5 added to the product of 2 and p is less than 11. This is really actually matching up, because 5 added, the plus 5, to the product of 2 and p, 2 times p, which is right there. This one says is at most, and if I go with the is at most, we are going to be talking about a less than or equal to situation. So that one's out. B is actually our best answer here. In example 3, it says 3 more than 5 times a number must be smaller than 93. So a lot of things hiding here. 3 more, so we're adding 3 on, then 5 times a number. We don't know the number, so we'll say 5 times x, which is really just 5x, must be smaller than. Smaller than signals to me that we need less than. It has to say under that. And 93. So plus 3, 5x, less than 93. So it's really 5x plus 3 is less than 93. Armadillo. So we get 5x is less than 90. Divide by 5. X is less than 18. What is the number? The number would have to either be x is less than 18, so the number could be 17, or smaller. In example 8, Mrs. Grabner wanted to buy big tubs of ice cream for the track team's ice cream social at $10 per tub. She already spent $23 on other supplies for the party, the bowls, the spoons, the toppings. If she wants to keep her costs under $100, how many tubs of ice cream can she buy? So $10 per tub. I want to get more than one of them, so that is going to get the x. And I already spent the 23, so plus the 23. And I want to keep my costs under, so less than, this is my equals number. So if I go ahead, minus 23 then, because that's my armadillo. So I get 10x equals, if I take away 23, I get 7, not equals, is less than, see, I do it too. It's less than 77, divide by 10. I'm going to get x is less than 7.7. So how many tubs of ice cream can I buy? What's the next smallest whole number that's under 7.7? Hopefully you're saying 7, so she can buy 7 tubs of ice cream.